Have you ever wondered what's actually anchoring our entire Milky Way galaxy together? For decades now, it's just been accepted as a fundamental, unquestionable scientific fact that a supermassive black hole, a cosmic monster we call Sagittarius A star, is lurking right at the center of our galaxy. But what if it isn't? What if the textbook is wrong, and the black hole at the center of our galaxy isn't a black hole at all?
Look, I know this sounds a bit like science fiction, but it's actually cutting-edge science. Just listen to this direct quote from a recent publication by the Royal Astronomical Society. They state, and I quote, "Our Milky Way galaxy may not have a supermassive black hole at its center, but rather an enormous clump of mysterious dark matter." It turns out this invisible, mysterious substance might actually be pulling off the greatest disguise in the universe, perfectly mimicking the gravitational pull of a black hole. So, let's dive right into this incredibly fascinating explainer, the cosmic imposter, dark matter versus the black hole. We're going to unpack the brand new research challenging everything we thought we knew about the galactic center, meet our prime suspect, and look at the upcoming space mission that's finally going to crack this cosmic case wide open. All right, let's start by establishing the scene of the crime. Section 1, the galactic center mystery. For years now, astronomers have been watching this specific group of stars, we call them the S stars, just whipping around the center of our galaxy at absolutely wild speeds. We're talking up to a few thousand kilometers per second. Now, to make massive stars move that fast, you absolutely need an incredibly dense, unbelievably massive object pulling on them. For the longest time, the only logical explanation we had was a supermassive black hole. But as our measurements have gotten sharper, a crazy new possibility has stepped into the spotlight. Which brings us to Section 2, the dark matter suspect. Let's meet the new candidate that might actually be pulling the strings. We're talking about something called fermionic dark matter. Simply put, this is a model proposing that dark matter is made up of fermions, which are super light subatomic particles. Now, here's where it gets really cool. Unlike traditional dark matter models, these fermions are subject to quantum mechanics. Because of something called quantum pressure, they can cluster together into an incredibly dense core without collapsing into a singularity like a black hole would. When you map this out, it brilliantly illustrates how this structure forms. You essentially get this super dense, compact core right in the center, which sharply drops off into a vast, diffuse halo around it. It's kind of like a giant cosmic egg. And the beauty of this single, unified model is that it bridges vastly different cosmic scales. That dense inner core perfectly explains the violent, high-speed dance of those S-stars at the center. Meanwhile, the fluffy outer halo perfectly matches recent data from the Gaia mission, which tracked the gentle rotation of stars way out in the galaxy's outskirts. It literally solves two massive problems at once. But how exactly does a clump of particles manage to fool the smartest astronomers on Earth? Well, Section 3, mimicking a black hole. Let's look at how this imposter pulls off its disguise. When researchers ran the statistics to compare the traditional black hole model against this new fermionic dark matter model, they found a stunning tie. Both models effectively explain the extreme orbits of the S stars and those weird dust-shrouded objects nearby known as G-sources. Current observational data simply cannot decisively tell them apart. From a distance, they exert the exact same gravitational pull. Now, you might be thinking, wait a minute, didn't the Event Horizon Telescope literally take a picture of the black hole at the center of our galaxy? Well, lead author Valentina Crespi points out something completely mind-bending. The dense dark matter core can mimic the shadow because it bends light so strongly, creating a central darkness surrounded by a bright ring. That famous glowing donut image we all saw in the news? Yeah, a super dense dark matter core surrounded by glowing gas would cast a shadow that looks strikingly similar.
Mathematically, it's almost a perfect match. If you compare the gravitational space-time metrics, which is essentially how space and time bend around an object, a 10 million solar mass dark matter core and a standard black hole overlap almost completely as you move outward. The space-time warping caused by this highly compact dark matter is astonishingly similar. It's only at the very microscopic center that the math actually diverges. To the rest of the universe, they wear the exact same mask.
So if they look identical from afar, what happens when you get right up close? Section 4, the accretion engine. This is where things get really wild. In a traditional black hole, there's a strict boundary called the innermost stable circular orbit, or ISCO. It's basically the point of no return. Matter can't orbit safely past this point. It just falls straight into the abyss. But a dark matter core?
It doesn't have an event horizon, and it doesn't have an ISCO. It's totally transparent. This means a disk of superheated gas can enter deep inside the core, falling incredibly close to the absolute center. And here is the kicker: 28%. Because matter can fall so unbelievably deep into the core's gravitational well, the accretion efficiency, meaning the amount of mass that gets converted into pure blazing energy, can reach up to 28%. To put that into perspective, a standard non-rotating black hole only has an efficiency of around 5.7%. This means a mere clump of dark matter can generate the kind of extreme power output we previously thought was only possible from a highly spinning black hole. When you crunch the numbers on maximum binding energy efficiency, our highly compact fermionic core easily surpasses a standard black hole. Because the particles in the surrounding accretion disk can survive so much closer to the center without getting swallowed up, it creates an absolute powerhouse. It's literally an engine that outperforms the very thing it's mimicking. So what does that mean when we point our telescopes at it? Well, the light emitted by an accretion disk around this specific type of dark matter core perfectly overlaps with the light from a black hole. Their luminosity spectra peak at the exact same spots. To our current instruments, they are virtually indistinguishable. It is, quite frankly, the perfect crime. But every criminal leaves a fingerprint. Section 5. Finding the photon ring. Here is how we administer the ultimate lie detector test. See, while the dark matter core can absolutely fake the shadow, it cannot fake the photon ring. A photon ring is this incredibly sharp, infinitely thin ring of light produced by photons that have been trapped by a black hole's gravity, slingshotting around it multiple times before finally escaping to hit our eyes. This feature requires an actual physical event horizon to exist. It is completely absent in the transparent dark matter scenario. If we can see the photon ring, it's a black hole. If we can't, we might just be looking at dark matter. The problem is, our current telescopes aren't quite sharp enough to see this tiny, subtle ring. Enter the Black Hole Explorer, or BHEX mission. Proposed to launch as a NASA Small Explorer in 2026, this mission is essentially going to extend the Event Horizon Telescope into space. By combining a space-based receiver with telescopes back on Earth, BHEX will produce the sharpest images in the history of astronomy. Its primary goal? To discover and measure that elusive photon ring. Between BHEX and the Gravity Interferometer down in Chile, we are finally setting up the ultimate lie detector test for our galactic center. In just a few short years, we are going to have the technology to look close enough. We will finally know for sure whether the massive gravitational anchor keeping the Milky Way together is a supermassive black hole or a spectacularly convincing dark matter imposter. Which leaves us with a pretty staggering thought to chew on. If this upcoming mission proves the dark matter model is actually correct, we won't just be rewriting the textbooks on our own galaxy. We'll be forced to ask, if our galaxy's heart is made of dark matter instead of a black hole, what else about the fundamental laws of the universe have we been getting wrong all this time? Keep your eyes on the stars, and we'll see you in the next explainer.